Here we're going to learn about classifying work. To help us with this, we have a case study. So please have a look at this particular case study. So what is that we observed? We have a lead box. Very simple case. It's being pushed to the right. Agree? So let's look at the free body diagram of the lead box during the push. So how do we draw a free body diagram? We represent the object generally with a rectangular box. So we'll have to show all the forces acting on it from the center, generally. So what is that we are looking at? We are looking at the gravitational pull. Equal and opposite force is present, which is pushing it up. That is a push by the table. Right, guys? This is the very basic. Just a second. Array, it's not going away. We have a very basic force, that is your gravitational pull, that is the weight of the object, and the push by the table. These are your basic force to begin with, and after a second I am pushing it to the right. So we have a push to the right, force by me, and of course this is a real world scenario. We have a push to the left as well. By whom? By frictional force. Agree? So this is your force of friction. Okay, FF. These are the four forces, and that's your free body diagram of the lead box during the push. So the object got accelerated to the right, and we can tell that the object moved or got displaced to the right. So displacement is to the right. Agree? Now let me just make this very clear. If this is the object, it got displaced to the right. Okay, so from here till here. So this is your direction of displacement. Point A to point B. Okay, guys, keep all of this in mind. We're going to make use of this to classify work. Now, remember, we classify work looking at the force from the perspective of force. Has this force done positive work or negative work or zero work? So let me introduce it to you guys. We're going to classify work as positive work, zero work. In zero work, there are two cases, and the third one is negative work. So we have positive work, zero work, and this is your negative work. That's how we can classify work as. Now, when is that we have the positive work? The condition is that the force and the direction of displacement are in the same direction. This is when we have the positive work. Okay, guys. So we have the object. If I happen to push it to the right, and the displacement happens in the same direction. Right? If this is a force and the displacement happened in the same direction, this particular work is said to have done positive work. Sorry, this particular force is said to have done positive work. If a person is pushing it, the person is said to have done positive work. If a machine is pushing it, the machine is said to have done the positive work. Or something is pulling it, that particular force is said to have done positive work. If an object is falling down, the gravity, right, is pulling it down, is it not? And the displacement happens to be in the downward direction. So the gravity is said to have done positive work. Are you getting an idea? So coming back to this, which of this force has done positive work? Yes, it's very clear. We have this force which has done the positive work. Basically, I have done a positive work. Okay, so I have done a positive work. Agree? Now let's look at zero work. So zero work is quite simple. This particular case, at least, we have an object, right? If I happen to push it, like say a wall, what if I push a wall? What happens? Remember, I'm not that strong. So what happens? The object will continue to be at rest. The wall will continue to be at rest. Of course, even you guys push it, If it's a normal strong wall, and obviously nothing will happen. Is it not? No way we are close to any superheroes that we see on TV, right? So nothing will happen. We won't be able to do anything to that other than leaving a mark. So in this case, there is a force that's pushing the wall to the right, but the object will not move, the wall will not move. It will be at rest. In this case, we have done no work. If you have a boulder, if you have a truck, if you try to push it, what happens? If you try to do it alone, there is almost nothing that is going to happen to it. Of course, if there's a lot of people and so on and so forth, yeah, something might happen, but we're just talking about a normal case wherein we are just pushing it with your bare hands, no tools, right? So in this case, we are said to have done no work. There's one more complicated case. This is the most complicated of all of them. Okay, guys. So let me explain this. I have an object. Listen to this carefully. I am pushing it to the right. But if it moves up, if not down, if the displacement happens to be this, or say I have an object, I am pulling it up or pushing it down, any one of that case, right? If the object moves to the left, if not right, the displacement happens to the left, if not right. Let me make this clear over here. The displacement happens to the left, if not right. Again, remember, this can be up or right or left. This displacement can be up or down. This is all of OR cases. I'm not showing all the small cases. I'm just showing it as 2 diagram. It's convenient, is it not? Right? If we see such a scenario, then the work is said to be 0. So this force and that force, in all of these cases, these 2 forces has done 0 work. Okay. Basically, the keyword here is perpendicular. Remember this. Perpendicular means what? Perpendicular means 90 degree. Okay, guys. People who don't know this is nothing but 90 degree. 90 degree between what? Force and the displacement. If the displacement is perpendicular direction of force, then we said to have done no work. So coming back to this example, which force has done 0 work? Yes, your table and the gravity have done 0 work. Agree? So basically, if I remove these 2 forces, if I don't even bother with these 2 forces, the object will have the same effect. Is it not? Okay, now let's imagine this. I just want to make this clear. I'm sure it might be clear to you guys. Most of you would have had it is very kind of clear, I guess, by now. If not, just let's close our eye. Think about this. You are out of space. So there's emptiness. It's space, right? And yeah, you are able to breathe and all that. Of course, somehow you are able to hold your breath. Let me put it that way. So in front of you, there's a table. On that table, there's a lead box, that is. Hope you are able to imagine that. Are you guys able to imagine that? Close your eyes. Now, see, there's nothing acting on it. There's no push or pull or anything. Table is not pushing the lead up, or there's a gravitational pull because it's empty. The space is, it's space basically. It's an empty space, right? So if there was a force, say you guys, if you push the lead to the right, there is frictional force. The lead box and the table are in touch, so there is frictional force. If you push it to the right, the lead box will, yes, move to the right. Agree? Whatever happened, whatever video you saw, that will happen. Even if there is gravitational pull, obviously there will be a normal force, that is push by the table. They'll cancel each other out. But in this case, we are just ignoring them, or we are taking them out of equation. We are imagining a space wherein there's nothing else. Okay, you guys also have 0 mass, so you are also not generating any gravitational field around you, right? It's just the table and the lead box on it. Are you able to imagine that? If the gravity and the normal force is not there, that will continue to be there. And say, you using your strength of your mind or something, you are able to push it a bit forward. Frictional force will act back and the object will move a bit forward and it will stop. Are you able to imagine that? So here gravity and the normal force did not play any role, is it not? So the contribution is 0, tollo. There is 0 work by them. Now you can open your eyes. So force of gravity and the table, the normal force by the table, have no contribution. That's why they have 0 work that is being done by them. Okay guys. So 0 work is done by any force that is perpendicular to the displacement. Keep this in mind. This is the only case which is tough. Everything else is quite simple, right? So all of the examples you guys need to write. So here is force of gravity. So this is under free fall, right? I'm making it clear. This is a boulder and all that. This is very convenient. Example 1 and 2. These two cases also you guys have to write. This is very important. And the third one is your negative work. The condition is that force and the direction of displacement are in opposite direction. Very simple. If you have a object, if I push it to the right, but it's moving to the left, basically it should be opposite. Doesn't matter. Okay, so again, I'm not going to talk about all the cases. If I push it to the right, it's to the left, the displacement is to the left. If I push it to the left, the displacement is to the right. Agree? If I push it up, the displacement is down. If I push it down, the displacement is up. If this happens, my contribution is negative. That is, I'm slowing it down. It's an important work actually. You guys can feel negative work is what is the use of that? Well, I'll explain the use. First is you guys have to answer which is that work which is doing negative work. Yes, clearly there's only one force left, that is your frictional force, that is doing negative work. Okay guys, right? So in this case, we have the frictional force doing negative work, gravity and the table force is doing 0 work, and I'm doing the positive work. If not for friction, this lead box would have not stopped moving, right? So yes, negative work is also important. That's why I told negative work is required, right? It's very simple. Push it to the right. If the object is moving to the left, it's negative work. Of course, in this case, the force is to the left, the pull is to the left, and the direction of displacement is to the right. So this particular force has done negative work. Very simple. Okay, so let me summarize. We can classify work as three things: positive, 0 or negative. So it depends on what? It depends on the direction of force and displacement. If they are in same direction, it's positive work. If they are in opposite direction, it's negative work. Very simple. 0 work, if the displacement is 0, then it's 0 work. If not, when it's perpendicular, this is the tough part. When things are perpendicular, right, then it is said to be 0 work. Okay guys, in terms of angle, it's a bit of extra information. Let me not tell that, it's kind of confusing for you guys, but if you want to write it and think over it, it's an extra work. That's kind of not homework exactly, but if people are interested, this is something that is a bit advanced, so you can make use of this and you can summarize over here. Okay guys, so I'm not going to do this work, that's your work. If you are interested, you can do it. If not, as per the syllabus and as per the requirement as an introduction, this is good enough, whatever we discussed. Okay guys, so now it's very important for you guys to pause, think, understand and write in your own flow. But yes, having all of this diagram and everything is important. Okay guys, so please pause and write all of them. From this you're going to get 1 or 2 marker pakka, and this is very useful for the future understanding of a lot of things, right? Not only 9th grade, higher grades also. So now you can pause and have a look at each slide and copy it off.